Question 8 asks us to simplify the expressions using exponent rules. So we first have to remember our exponent rules. Exponents represent repeated multiplication. So when we're multiplying with a common base, we add the exponents. So for instance, letter A here, they both have a base of y, and we're going to add 5 and 7 to count a total of 12 y's being multiplied together, so we get y to the 12th. Same thing for letter B. B is our base for all three, so we can add the exponents. 4 plus 3 is 7, plus 3 is b to the 9th. There are 9 b's being multiplied together. It works for letter C as well. 8 to the 4, 4 coming from 6 plus a negative 2. Now the next rule is when we have an exponent raised to an exponent, we multiply the count, the total variables being multiplied together. So if we have y to the 5th raised to the 2nd power on letter D here, we need to multiply 5 times 2 to get a total of 10 y's being multiplied together. We have to be very careful on letter E because we have 3 to the 1st power and a to the 1st power as well. So when we multiply in the 4, we should get 3 to the 4th times a to the 4th. The next rule is when we're dividing with common bases, we subtract the exponents to count the total of variables being multiplied together. So we have m to the 5th, 8 minus 3 is 5. Letter G represents dividing when we have a constant. Constants act as normal. 12 divided by 6 is still 2. And when we do 8 minus a negative 3, we get m to the 11th because subtracting a negative is like adding. H is distributing the 3 again, so we should get x to the 9th, y to the 6th. Order of operations for letter I, we need to multiply the 2 times the 4 to get 8 total y's being multiplied together on top, 6 on bottom, and that reduces to a total of 2 because 8 minus 6 is 2. Letter J has multiple bases happening. There's a constant. 15 divided by 3 is still 5. The y's cancel out, and here's the problem. If we subtract 2 minus 4, we get negative 2. We always want our final answer to have a positive exponent. So 5 is going to stay on top of the fraction. A negative exponent jumps from the top to the bottom, becoming positive. So we get 5 over positive x to the 2nd power for our final answer. Different things to keep track of for letter K. We're going to multiply the constants like normal. 4 times 3 is going to give us 12. There are 4 c's being multiplied together in the first parenthesis, 3 in the second, 1 in the third, so that gives us a total of c to the 8th. And we have a total of a to the 6th, 1 in the middle parenthesis and 5 in the third parenthesis. We're going to distribute the square through letter L here, so 7 squared is going to be 49. If we can simplify that, we should get x to the 6th power when multiplying and y to the 10th power. Our last column here, we need to start by order of operations, so distributing the 3, so we get 2 to the 3rd, y to the 3rd, and then we're going to multiply that by 4xy to the 2nd. In order to multiply the constants, we have to know what 2 to the 3rd equals. 2 times 2 is 4, times 2 is 8. So we get 8 times 4, which is 32. We have x, and then we have y to the 5th because we have 2 in the first parenthesis and 3 in the second. Letter N, we need to raise each numerator to the 3rd and then the denominator to the 3rd as well. We're going to multiply 2 times 3 to get x to the 6th. And letter O has a negative exponent, so we're going to rewrite that as a fraction. It is on the top of the fraction currently, so we're going to move it to the bottom of the fraction, make it positive. If nothing's on top of the fraction, we're left with 1.